Hello and welcome to Bharat 16.in. We continue with our technology series today. If you recall, in the last episode that we had, we talked about artificial intelligence. That was actually the part one of the episode. Today will be the part two, when we'll continue to talk about several other issues about artificial intelligence. Just for a brief recap, if uh, to just put it across to you what we did talk last time, well, we had talked about AI in a simplistic, in a generalistic way to start with. Thereafter, we've gone down to the dividends that are there as far as AI is concerned to any organization, and with a special reference to the armed forces, of course. And finally, we had tried to wade through and find out what are the priority areas for AI application in the armed forces. Today we go ahead further and let's see how does the discussion go. I have with me a very erudite uh, guest, Lieutenant General Anil Kapoor. Right, General, we'll continue with the discussion
Yes.
that we had last time. And like I just recall, what did we really discuss the issues last time? The first issue that I want to discuss with you today is what are the pluses and minuses as far as AI is concerned, keeping in view it's being an enabler. What are the pluses and minuses, and how do we go about this whole thing?
Right. Let me begin again by saying that, AI is something that started happening in 1950s. However, it was contingent upon two basic things. One is data and the other was computation speed. Because we were looking at, when we look at artificial intelligence, we look at predictive analytics. And when we look at predictive analytics, I think trends and patterns are very important. And as many data points you can pick up and as fast you can compute gives you that much more faster predictability and more accurate predictability. Now, let me share an anecdote to explain this a little better as an enabler. Way back in 1990, I did a project on artificial intelligence for a guidance control relationship of a missile. That time, the best chip I could get was giving an update at 100 milliseconds. So what we were doing was we were simulating a target which got simulated every 100 milliseconds, and I had a chip which would read it and feed it to an algorithm. The AI algorithm was called Kalman filter. It was a mathematical filter, something which we made it a little adaptive. And then what we realized was it took us 1 second, that means 10 updates, to be able to predict the future position of the target accurately using that filter. So what the filter would do was, it will pick up the present position of the target, but the missile should get the future position of the target when the missile reaches the target. So it would always point the missile towards the future position. And there were inaccuracies till about 10 iterations. At the 10th iteration, it would catch it, which would mean 1 second it will take to stabilize. Today, the same thing actually gives you an update almost at 1 microsecond or even less, depending on your computational speed. So therefore, what I'm talking of a second can actually happen in milliseconds today. In the time in which I was picking up one update, actually you can solve the whole algorithm. And that's why today data and computation has made artificial intelligence actually the key enabler. And you pick up any data point, it will be able to give you a futuristic prediction with accuracy. And therefore, the whole world is moving from automation to autonomy. So the two key enablers therefore are data and computation. We call it cognitive computation. And then you have allied technologies. Today you have a lot of sensors which have come up, huge number of sensors. Nanotechnology, bringing in nano sensors. We've got communication, a very fast speed communication, high speed communication. 5G or aware is already there. Technology panorama. And then, if I may say, in times to come, what electricity is to our life for the last so many years, AI will be to our life in years to come. It is going to be the lifeline of all existence.
Right, General. The next issue which I would like to go into, and AI has a huge amount of application, as I see it, in our improving our MRO capabilities, maintenance, repairs, overall the capabilities that we have. Now, in fact, the entire life cycle maintenance process perhaps requires AI application, one hugely, I would say. Especially let's say when we have so much of equipment which is technologically so advanced. So what do you have to say about AI application in MRO, repair and recovery?
That's a very brilliant question again. Actually, today when we look at any outfit, now there's an industry, which is a production unit, and MRO is a life cycle sustenance support. And AI today actually has become the nucleus of both. Now, in the industry today, they are progressing from industrial automation, which is Industry 4.0, to industrial autonomy. That means you need not use as much of human effort. You could actually carry out all operations, including decision making, very seamlessly. And today it's called IA to IA, that means industrial automation to industrial autonomy, has become a great thing in the production units. And top of the line industries actually started acquiring IA to IA, whether it is aircraft industry, auto industry, and others. That's something which is work in progress. Now, once the equipment gets produced, there comes the life cycle sustenance support. You and me are aware that, from our childhood days in the armed forces, we've been looking at something called periodic maintenance and something called preventive maintenance. And both these things actually, over a period of time, we realize now have resulted in over maintenance. With sensor technology coming in today, let me say in a minute, in an inch of a space, you get miles of data on the behavior and performance of every assembly and sub-assembly in the equipment. And each of these data points actually tells you a story. It tells you a story of the condition of that particular component. And if we were to look at it from an AI perspective, it will divide it into 3 zones: green zone, amber zone, and red zone. Green zone is a zone and you don't need to think about that assembly or sub-assembly. The sensor is telling you all is good. Amber means that there's a need to take some action in terms of either a preventive maintenance or a periodic maintenance. And that will be something like just-in-time maintenance. However, it is still not a red flag. You have the time to either acquire the spares or acquire the lubricant or require whatever is required to carry out that maintenance. When it touches the red is when you've actually taken optimum life out of that assembly or sub-assembly, and that's the time when you should actually go in for a change. Now, what we have seen is an engine, as an example, in an aircraft, which was being overhauled at 250 hours, have we subjected it to a condition-based monitoring using sensors and artificial intelligence up to 650 hours. That means nearly 3 times the life. Imagine how much of life we have not used in an engine that we removed. And therefore, when we look at the MRO, it is indeed a MRO best practice to put it in the design and development stage into the system so that when you are actually exploiting it, you are doing predictive and prescriptive maintenance rather than periodic and preventive maintenance. It's hugely cost effective and your life cycle costs go down. More importantly, as a user, you're always very confident that your equipment has adequate residual life and your mission or combat readiness is well assured. So that is one advantage that AI will give you in the MRO space.
Well, that's a huge savings, I would say, when you give that comparison of 250 hours of flying, and well, you could be actually doing much more. However, let's get on to the next issue, and one issue which will, I'm sure, interest our viewers one quite a bit is the fact of how are we placed as Indians in comparison with the Chinese? Are we on the same board? Are we ahead of them? Are we behind them? What is the status as you see it?
Okay, Brigadier Chatterjee, you asked a question actually which you also know the answer of. China is today the AI superpower. I mean, they've even beaten America at the speed at which they've incorporated artificial intelligence into their nation first and PLA plan and PLAF. They've got a strategic support force which is dedicated to emerging disruptive technologies. And they're looking at how do they incorporate them and create a public-private model. We all have heard Alibaba and its astronomical rise, all based on artificial intelligence by and large. So really speaking, while they have exploited hell of a lot in the CV street, and I would not like to dwell more on it for want of time, but in the defense forces, they are actually carrying out huge amount of innovation strategies for bringing in artificial intelligence. Now, uh, areas are space. Let's start from space downwards. Space is an area where huge amount of AI and predictive analytics is being done. Then cyber is another great area where you can actually carry out a lot of cyber defense and a huge amount of cyber offense. So it's another good space. Then you have unmanned autonomous systems, unmanned aerial autonomous systems, unmanned land-based autonomous systems, unmanned sea-based autonomous systems, and unmanned underwater-based autonomous system. All of them require artificial intelligence for decision making. And to put all this together, they got something which they are working on, C7ISR. Command, control, communication, computers, cyber, cognition, and combat. That means you got a full autonomous system in place between a seeker and a shooter. And to augment this, they are looking at unmanned autonomous guns, unmanned autonomous AFVs, unmanned autonomous aerial platforms, which we also have. So there'll be a manned-unmanned system on ground, autonomously controlled or semi-autonomously controlled, and a step forward is robots. That means a combat force of robots. So really speaking, in times to come, that's a great area to be in, that you have a unmanned force which is quite potent based on real-time information, which is the first respondent. And once your first respondent shapes the battlefield for you, come the actual troops to actually mop up and reorganize and take control. So that is one scenario which they're calling lethal unmanned autonomous weapon systems or weapon platforms. So that is the area. And of course, we talked of MRO. Predictive maintenance is very much part of their plan as we have seen it. And therefore, AI is actually ubiquitous to all the domains of warfare and even in civil life. And that's why they are doing a good PPP model. I think we are also, though in a lag mode, but we are there. We are very much moving forward into various fields of artificial intelligence. We are looking at artificial intelligence platforms. We are looking at various enablers. And I wouldn't say that, I would just say that the best is yet to come. I wouldn't like to offer any comparisons at this stage, but I would only say that I think we are there. There's a lot of work done. There's a lot more which has to be in progress. And it is going to be, if I may say, a race to the swift. Because technology today, it is not only about AI, it is a huge amount of information systems that are supported by AI, which also have to be in place for integrated and joint C7ISR, if I may say. That is where I think once we achieve, we would have gained parity as far as technology is concerned.
Well, thank you so much. I think that was a wonderful talk that you gave us on artificial intelligence. And I hope to continue with this technology series with you, General. Thanks a lot.
Thank you. Thank you very much. It's very interesting and all the best.
Right. And thank you, viewers. Thanks for logging on to bharatshakti.in, and do log in with us now and again, and you will find such interesting subjects. Do like us and do share whatever we produce. Thank you.